to the channel. I'm Kim Ivy Noveros, and let's get ready to expand our knowledge, ignite our curiosity, and dive into the fascinating world of blockchain. Just imagine a world where every transaction, every piece of information is stored securely and can't be messed with. That's the magic of blockchain. So blockchain is like a super secure digital ledger shared across many computers. Once the information is recorded, it's almost impossible to change. It's revolutionizing how we trust and handle data online. Cool, right? Blockchain is like a digital ledger that stores transaction records in blocks, which are linked together in a chain. This chain is shared across a network of computers, making it really secure and hard to mess with. It is changing how we handle data online. So, in the world of blockchain, every transaction is like a digital contract signed by the owner. This signature makes sure the transaction is legit and protects it from any funny business. That's why the information in blockchain is super secure and almost impossible to mess with. Isn't that awesome? Think of the digital ledger in blockchain like a huge Google spreadsheet shared among tons of computers. It keeps track of all transactions, like purchases. But here's the kicker. While anyone can see the data, no one can mess with it. It's like having a transparent record that's super secure. How cool is that?
Hi guys! Are you ready to know how blockchain works? If yes, I'm Kate CABAHUG and allow me to discuss with you how blockchain works.
Firstly, a user or a node will initiate a transaction, signing it with its private key, which generates a unique digital signature. That action creates a block that represents that specific transaction or data. After that, the transaction will be broadcast to the verifying nodes, and once verified, the transaction is placed in the ledger, which links up to the previous blocks and creates a chain of blocks. Thus, the name blockchain.
There and now, let's identify the advantages and disadvantages of blockchain. Let's go!
First, blockchain enables tokenization. It empowers individuals with limited access to wealth, democratizing business and industry by allowing them to participate in opportunities previously excluded due to financial problems. Next, blockchain is decentralized, means no bank or entity controls blockchain, which some thought as its biggest advantage. Blockchain is fast and cost-effective. It speeds up financial transactions. And lastly, blockchain is transparent, means anyone with access to a blockchain can see what's in it. Disadvantages: blockchain has low adoption. Also, blockchain is immutable. Data immutability has always been one of the biggest disadvantages of the blockchain. Means what's put on the blockchain stays there forever. Blockchain has private key issues. Blockchain addresses are made up of individual private keys. If the person loses their private key, the process turns into a failure. They can do nothing to save their money or for their transaction procedures. Lastly, blockchain is extremely volatile.
Hey there, I'm JAMBY CANDAR, and this time we'll talk about the application of the blockchain. So, let's go!
Blockchain is an emerging technology that is being adopted in innovative manner by various industries. We describe some use cases in different industries in the following subsections, which are the energy, finance, media and entertainment, and retail. Blockchain-based energy companies have created a trading platform for the sale of electricity between individuals. Homeowners with solar panels use this platform to sell their excess solar energy to neighbors. The process is largely automated. Smart meters create transactions and blockchain records them. With blockchain-based crowdfunding initiatives, users can sponsor and own solar panels in communities that lack energy access. Sponsors might also receive rent for these communities once the solar panels are in finance. For example, Singapore Exchange Limited, an investment holding company that provides financial trading services throughout Asia, uses blockchain technology to build a more efficient interbank payment account. By adopting blockchain, they solved several challenges, including batch processing and manual reconciliation of several thousand financial transactions. Copyright verification is critical for the fair compensation of artists. It takes multiple transactions to record the sale or transfer of copyright content. Sony Music Entertainment Japan uses blockchain services to make digital rights management more efficient. They have successfully used blockchain strategy to improve productivity and reduce costs in copyright processing. In retail, for example, Amazon Retail has filed a patent for a distributed ledger technology system that will use blockchain technology to verify that all goods sold on the platform are authentic. Amazon sellers can map their global supply chains by allowing participants such as manufacturers, couriers, distributors, and users and secondary users to add events to the ledger after registering with a certificate. Blockchain technology has a few interesting applications within the computer science world. Though it's not directly used in the same way it might be for cryptocurrencies or supply chain management, here are a few examples. The first one is the Secure Boot and Trusted Execution Environment, or TEES. Blockchains can be used to create a secure chain of trust for a computer's boot process. This can ensure that only authorized software is loaded during startup, protecting against malware. Similarly, TEES can leverage blockchain to create isolated environments for sensitive tasks like storing cryptographic keys, where code execution is tamper-proof. The next example is the decentralized file storage. Blockchain can be used to create decentralized file storage systems. Data is encrypted and stored across a network of computers, eliminating the need for a central server. This can offer greater security and redundancy compared to traditional cloud storage solutions. The third example is the software licensing and distribution. Blockchain can be used to track software licenses and manage their distribution. This can help prevent piracy and ensure users are getting genuine software. The last example is the digital identity management. Blockchain can be used to create secure digital identities for users. This information can be stored on a blockchain and accessed by authorized applications, reducing the risk of identity theft and simplifying login processes. While these applications hold promise, there are challenges to consider. The first one is the scalability. Blockchains can struggle with large amounts of data which might not be ideal for storing all computer files. And then, the performance. Verifying transactions on a blockchain can be computationally expensive, potentially impacting system performance. The third is the regulation. The legal framework surrounding blockchain technology is still evolving, which can create uncertainty for businesses considering its use. Overall, blockchain offers new possibilities for computer security, data management, and identity. However, technical limitations and evolving regulations require careful consideration before widespread adoption.